Question 8 is our first quote-unquote business calc problem here. This is just another little algebra problem. They're trying to have us create, first they want us to find a cost equation, then they want us to find a revenue equation, and then from that information they want us to find the break-even point, how many calculators it'll take to break even. So all of these are going to be using a y equals mx plus b setup. Your m in these situations is always the rate. So how much you're charging something, oftentimes they'll call that your variable revenue or your variable cost because it changes depending upon how many items you sell. And then the b out here, that's a constant. That's usually going to be what your fixed costs are, the costs that you can't get away from or the revenue that comes no matter what. So it doesn't vary at any point, it's just a constant value. So we'll start off by creating our cost equation, our C of x right now. And when we look into the language of the problem, what we can see is that we have a fixed cost here of 136,000. So fixed costs are our constants. So they're actually giving us the B portion of this. So, and thinking about this in a y equals mx plus b setup, we now know what the B is. Our B is going to be that 136,000 there. And it's positive, so we'll have a plus on it. The variable cost, they're telling us, is estimated at $16 a calculator. So the variable cost, that's our rate. That changes depending upon how many we sell. That's our slope right now. So our slope here would be 16x. So that'll be our cost equation right there. And then they want us to come through and on the next piece create ourselves a revenue equation. So the revenue in this one is only got a variable piece. We don't have a constant. We just know that we sell each of our calculators at $50 a piece. So 50 calculators, and then we don't know how many we're selling, so that's going to be X. X is just the quantity of items that we sell. So that'll be your revenue equation. And then to find your break-even point, the break-even point is the point where cost is equal to revenue. So where these two graphs are equal to each other, that's going to be your break-even point. And to find that, we're going to do that in our calculator. What we'll do is we'll take our cost equation and plug that into y1 on our calculator. We'll take our revenue equation and plug that into y2 on our calculator. So y1 is going to be the 16x plus 136,000. The y2 is going to be the 50x. From there, we're just going to go ahead and graph those two equations and go through a second calc, and in that calc menu we'll choose number 5, which is intersect. The place where any two graphs are equal, or in this situation a break-even point, is where their graphs run into each other because they share a common point, and conveniently our calculators will calculate that for us all day, every day. So we open up the calculator, go into our y equals, and then type in our cost equation, which is that 16x plus 136,000. And then the revenue equation, which is 50x. So we hit graph right now. And when you hit your graph, you can see one of the graphs cutting straight through 0 right there, but you can't see the second graph. So we know we're going to need to move our window around. The first thing I do in a situation like this is I go ahead and I hit the trace button once. And whenever you hit the trace button, it is actually on this graph, that point that you see at the bottom of the screen right there. So I know I've got a y value of 136,000. And if I hold to the right, I can see that this y value is still going up. And so what I want to do right now is I'm going to start by just kind of pushing my y max above that 136,000. So I'll put that up. I don't want to play this game all day, so I'll kind of double it. Maybe I'll try it out at 300,000. When you're doing the y's, it's always better to be too big than too small. So then we'll graph that. And so I can see the blue line and the red line, but they're clearly not anywhere close to meeting up. So I'm definitely going to need to move my x max out. I'm going to move my x max to the right here. When I move my x's, I don't usually move them nearly as much as my y's, so I'm just going to put this out, to something more reasonable like 5,000. We'll graph that. And there you can see that we got our actual intersect. So there's where the revenue and the cost are meeting with each other. So now we're going to do our second calc, And then in that calc menu, we'll choose number 5, which is intersect. It's going to ask us the same series of 3 questions every time. The first 2 we could care less about. It's first saying, is that the first curve? And it's on the blue graph. Yep, hit enter. That's the first curve. It moves to the second curve automatically. Is that the second curve? Yep, hit enter. And then guess, you just want to scroll up so you're closer to that intersect right there and hit enter. And at the bottom of the screen, you can see that we have 4,000 and then y equals 200,000. So the x value is 4,000 and the y value is 200,000. And so this is our break-even point right there. And they want to know how many calculators we should sell. Well, that's the number of items that we sold. So that is our number of calculators right there, our x value. And so our answer on this one would be 4,000.